Hello! In this lesson we're looking at triangle congruence, angle, side, side, and side, side. Our essential question: what does the angle, side, and side triangle congruence theorem tell you about triangles? Postulate 19, side, SSS congruence postulate. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. If side line segment MN is congruent to line segment QR, which are these two line segments here, MN is congruent to line segment QR, and we know that they're congruent because they have one tick mark on the sides. And side line segment NP is congruent to line segment RS. NP has two tick marks, which means it's congruent to RS, which also has two tick marks. And line segment PM is congruent to line segment SQ. Line segment PM has three tick marks, which means it's congruent to line segment SQ because it also has three tick marks. So I have a side of triangle M and P congruent to a side of triangle QRS. So we can say that triangle M and P is congruent to triangle QRS using the side congruence postulate. Example 1, using side congruence postulate, prove that triangle DEF is congruent to triangle JKL. In order to prove triangle congruence, we need at least three pieces of information. Looking at the diagrams, I can see that line segment DE has three tick marks, which means it is congruent to line segment JK. I can also see that line segment EF, which has two tick marks, is congruent to line segment KL because they both have two tick marks. And that line segment DF, which has one tick mark, is congruent to line segment JL, which also has one tick mark. So line segment DE is congruent to line segment JK, line segment EF is congruent to line segment KL, and line segment DF is congruent to line segment JL, and that's our given. I have three pieces of information over here. In this case, I have that the sides of triangle DEF are congruent to all of the sides of triangle JKL, and since I have three pieces of information, I can say that triangle DEF is congruent to triangle JKL using the side congruence postulate. Postulate 20, side angle side, or SAS congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. This is really important to understand that the angle between the two sides, I call it an angle sandwich, is congruent to an angle between two sides of another triangle. When you have this case, then you can say that triangles are congruent using the side angle side congruence postulate. So if line segment PQ, which is this side over here, that is congruent to line segment WX. We know they're congruent because they only have one tick mark. We also have angle Q congruent to angle X because they only have one arc. And that line segment QS is congruent to line segment WY because they have two tick marks. Notice over here I have a side, an angle between the two sides, and another side congruent to a side, an angle between the two sides, and another side. So I can say that triangle PQS is congruent to triangle WXY using the side angle side congruence postulate. Example 2, using side angle side congruence postulate, prove that triangle SYT is congruent to triangle WYX. From the image, we can see that line segment TY, which has two tick marks, is congruent to line segment XY because they both have two tick marks. We can also see that line segment SY is congruent to line segment WY because it only has one tick mark, and that's our given. Since we have two intersecting lines, we know that angle 1 is congruent to angle 2 because they are vertical angles, so angle 1 is congruent to angle 2 using the vertical angles theorem. I have three pieces of information over here. I have two sides congruent to two sides of another triangle, and I also have an angle between the two sides congruent to an angle between the other two sides. And so I can say that triangle SYT is congruent to triangle WYX using the side angle side congruence postulate. Postulate 21, angle side angle ASA congruence postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So think of this as a side sandwich. In this postulate, we are given that angle A is congruent to angle D because both of these have one arc, and the side of line segment AC is congruent to line segment DF because they have one tick mark, and angle C, which has two tick marks, is congruent to angle F because it also has two tick marks. So in these two triangles, I notice that I have an angle, a side between the two angles, and another angle congruent to an angle, a side between the two angles, and another angle. So I can say that triangle ABC is congruent to triangle DEF using the angle side angle congruence postulate. All right, that's it from me. I'll see you all soon.